Hello everyone. So I know this is very late, but I've had some issues at home currently, which I can't really talk about. Um, but I thought I'd go over some VEX, and I'm sorry if I'm a bit quiet. It is like 1 a.m. Some VEX and some quick ways to what's the word? Get the result using a copy the points instead of a copy stamp. So I'm going to have um, just two different animations so that we can see me going through both of them. So I should have actually prepared this properly. So I can use A or B, or it doesn't really matter what I use. I'm just going to use two zeros here. So, and I'm going to showcase how I do it. And I'm just going to quickly save them to the frame range. Shouldn't take too long. Almost instantaneous, really. And all I've done here is I've zeroed them out so they're on the ground floor, like so. And then I've done a H script expression where I've taken a sine wave function of the current frame and I've sped it up, so I've times the frame by 12. I've then times the sine wave by 2 so that it's going in because the sine wave goes from -1 to 1, so I've just made it so that it goes from -2 to 2, and then I've done absolute, so basically it'll just bounce on this floor, so it won't go, if it goes in the negative zone, it'll just flip it around. Okay, so I'm going to lay down a file node quickly, and I'm going to just paste this in here for now. I don't actually need this. I'm going to reference this later to what I need it to be. So I'm going to lay down the grid very quickly. And let me think. So what I want to do is, well, first of all, I'm going to do an add here, and I'm just going to delete the geometry, so we just got the points. And I'm going to change my background so you can see it a little easier. I can either set a p-scale currently, or I can just go as it is. So you've got to take into account here. So even though my uniform scale is at 1, if I put a box down, you can see there's a size difference. And if you middle click, you can see it's size by 2. It's because this is a radius, not an actual size. And a radius is like the length from the center to the exterior. So that's what radius. So you just got to remember that part. So what I want to do is I just want to get the distance between the two, all of these, and the easiest way I can do that is I can just get the distance between 0 and 1 because it's just a grid. So I'm going to say vector pos 0. Let's get the point 0 p for 0. So I just want the first point. Then position 1, and there's two ways I can get the distance. So I can say float dist. There's two ways I can use a distance expression where I plug in the pos 0 and pos 1. It'll give me that result. Or I can say distance equals the length of pos 0 minus pos 1. I think it actually might be the way around. Yeah. And that'll give me the same result, I believe. So if I say f at d1 is dist, and then f at d2 equals dist, again, we should technically see the exact same result here as we can. I'm just going to use this distance function. And this distance function, I'm just going to put it to the p-scale for now. So I'm just going to say f at p-scale dist. I'm going to change the p-scale later. And in here, I'm just going to be getting this one. And I'm going to do a copy to points quickly, just so I can get a sense of scale. So I know that this is a radius of 1. I want to halve it, basically. So times 0.5. So if we remember our mathematics, think it's BIMDAS is the one we want to remember, which is an order of operations. And in the order of operations, the multiplication is before division. So I've always, if I wanted to halve something, I always use multiplication. So I multiply it by 0.5 and I will just halve it. The reason I do this is that I know exactly in what order it's going to be going. So I've halved that, and then now I can basically fit this range between them two. So I can say f at p scale times equals random of current point number. So I want to fit range this. So the random goes from 0 to 1. So channel float min and channel float max. So, and I'm just going to keep this to 1. This one's about 0.4 basically. If I wanted to change seed, I would add a seed at the start here, so that it would see that it's a float. And so we've got like a seed, and it's copying quite nicely. But how do we change? I want the smooth one, not the displaced one. So what we tend to do instead of this is, and there's multiple ways of doing this. So we can either use a file, and we can use multiple files, or we can bring them all in at once and then just use a blast to get rid of them, or switch. I'm going to try and do it with just the file node. I don't know if it's advised, but what we want to do is we want to say if we want to get the attribute of this point here, and we want to drive the string from here. And what I'm going to do here is, so I know that I can either have O1 or O2. So what I'm going to do is I'm going to make a string value. Actually, I'm going to use a new wrangle. Just a new wrangle. So this one's just scale. And this one's going to be for strings. So strings. So. And I don't know if this is going to work, but what I want to do is I'm just going to make a quick string channel. So I'm going to say channel s input. So, and then I'm going to cast that to an s at input here. So now we've got input. If I just middle click, we're getting that. I'm going to go to edit parameter interface, and instead of the string, I want to give it instead of, which one do I want? Is it string? Yes, no. I want to get a file. So I'm going to say file, just file, basically. It's just going to be a read only. I don't really mind. So what I'm going to do is I'm going to grab this one in here and just paste it. And we can see that now we're getting an evaluated one. Yes, it's going to my user folder. I'm not very bright tonight. And what I'd like to do is, instead of this, I'd just like to have like replacements. So let's see if we can do like a D like that. And what I've done here is I've put in a replacement for me to go inside here and flip between. So what I can do is, it depends on how many I want. So I'm going to make a random value first. So I'm going to say int r. It's going to be random for the point number. It's going to throw an error because we want it to be it's going from 0 to 1, and that's a float value. We want to actually cast it to a proper value. So I'll show you quickly. So it's just going to be 0 all the way through because it's just being cast down. So I'm going to say rint that, which is going to round it. Basically, we can see it's going from 0 to 1. If I'm also going to cast it as an integer so that it stops complaining, it's not going to change the fact though. Finally, I want to put a fit range between this. So I'm going to say fit by1 so that if I have more values, I can do more. So which one do I want? I want this one. So channel float min, which will normally just be 0, honestly. So, and then channel float max. So I'm just going to say max here. And I've marked up the amount of what I need. And that should have actually been a channel int, honestly. So I'm going to go back here. I'm just going to delete this. and then I'm going to reinstate that, and now we can see it's going between 0 and about 4. Yeah, so I'm going to set it to about between 0 and 1 because that's all I've got to work with. Now inside here, I can, because I've been given what I want basically from this, I want to set aside the, I want to figure out which one I'm getting first. And I'm also going to go over here, and instead of report there, I'm just going to say no geometry so that it doesn't throw a hissy fit. And in this round here, I could easily say, so what I can do now is I'm going to say s input equals sprintf, which is a formatter. So I can first of all say s, I believe, and then inside here I can say s input, in a sense, and that's not going to change anything. But then I'm hoping I can now put in another value here. No, I cannot. Okay. I was hoping what I could do is I could put like a value in between here. However, it doesn't seem I'm able to. So another method I could do is instead of this, I would have two inputs. So I'm going to input folder and then just input. Keep it like that so that nothing happens. In the input folder, we're going to basically switch these around. So I'm going to go to the input folder, bring it up here. I'm going to say it's a file. It's a file directory. If we go like that, then we're going to get like a directory sort of thing, so on. I'm just going to quickly paste this in. In the input, I'm also just going to go up, and I'm just going to change that just to a standard string, like so. And I'm just going to call it that as quick anim. And inside here now, what I can do is I can say a string folder, and then string input. And so what I'm going to do then inside here is I've got s for the, I can put in like an s here, and then I can do another s. So inside here, what I'm going to do is I'm going to say folder, and then input. I'm going to get rid of that 134. And so instantly what's happened is we're also going to get like an error here, as you can tell. So there should be a better way of doing this. Let me quickly go to the documentation to see if I can actually get around it. I don't think I'll be able to. We can use regex, but if you've ever heard of regex, then you'll know why I'm a bit hesitant on using them, because they're quite difficult to figure out. So inside here, let's do like a $$D sort of thing. And in this input, I'm going to say folder. And oh, okay, now we're seeing it is actually working, almost, basically. So I can just go like this, and then I can say $D, $D, $. I can give it another type, but I'm just going to say $D and bgo.c. So inside here, I'm going to get rid of this input. In this folder, I'm going to say it's just say 2 for now. So if we go inside here, we can see the first one has now been selected. So instead of that, I'm just going to say I at R. And then I'm going to say I at R again, R. And then finally, we need to use like a frame. So I can say $, I can say that frame. And that's not going to be the correct frame though, unfortunately. We need to pad this with zeros, and there's a function in Houdini called pad zero, where you give it the current value. Well, I mean, you give it the size and then the value. So I'm going to say 4, and then the frame. And why aren't you doing anything? Oh, because this is a string value, so I'm going to say $S, possibly. No, I'll keep it the $Z for now. So apparently this is going to return a string, so I'm going to say frame, like that, then I'm going to say frame here. And it doesn't seem to like... Oh no, this is an expression. Ooh. Wonder why I thought it was a VEX expression. However, you can just use the same sprintf here. So what I'm going to do is I'm going to say sprintf, like so, then at frame. So I'm just going to get rid of this, and inside here I can say $, 04, yeah, like so. And what that'll do is it'll give it like a padding of 4 zeros in front of it. So now that's not going to affect this at all. So how do we make it read this what we've just given it? Well, the easiest way to do that is to use a for each, and we go over for each points, and this is the recommended way that Houdini is now promoting over the copy to stamp method. So I'm going to plug this in here, plug this one in here, and it's going to be the exact same output as we had before. But inside here, what I'm going to do is I'm going to delete all this, and I want to get the string from here. And we can't exactly get it from here. We want to get it inside this loop, otherwise it's not going to work, because we want to get the current point. So each point has its own different input in here, and I want to make sure that I know which that this is grabbing the correct point. Because we're going over each point, we're just going to get one. We could just get the 0th point, which is why it's so easy. So what I'm going to do is I'm first of all going to put that in null, just so that I know what to read in from. And inside of here, I can either reference it directly, or I can get it from a spare input. And the way I can do that is I can go to this little cog up here and say add spare input, and drag and drop it in here. And you'll notice now that we've got this purple line connecting it, as well as the compile block is now, or the block itself has now extended around it. So I'm just going to call it read in. And now we want to get the current string, so I'm going to say point. I don't think this is going to work. So say, I think it needs to be in, what's that word? What is that word? The tilde key. So to access the spare input, instead of saying 0, 1, something like that, we say -1, and we go down the negative zones. So we're going to say -1, 0, because I just want to get the 0th point. Input, because that's the name that I want to get, and then 0 for the component. So the 0 at the end is going to look for an X, Y, Z, W, whatever. If it's like a vector, then you can get X, Y, Z. If it's a quaternion, you get X, Y, Z, W. Because we're just getting a string, it's just going to have one value, which is just going to be 0. This isn't going to work too well, because I believe we need to use the word points, which should be getting... We get rid of this then. Nope. We should be able to get it so that it actually reads in the value. I keep saying it's a bad input. That's fine. So yes, that's the correct one. Unable to read the file points. So it should be reading in this here. Let's try points. I'm not too sure why it's not getting my current. Oh, right. So we can only have like 3 values because points and point is different. So points with the s at the end is going to get a string value. So we're going to, the first one is going to be the surface node, second the point number, then the attribute name. So 0, I know what it is. Now we're going to get the proper value, and we're still not exactly reading it in. Unable to read in from this because these actually have a 0 in front of them. So what I'm going to do is inside here I can say $01 like so. And it's not going to work again. There we go, 02, sorry. 01 is just going to get the first value. 02 is what we want. So now we can see we're getting some of them are being rounded, some of them are being offset like so. But what we are actually also seeing is that, for one thing, they're all going to be the same animation. But we're getting different values. So now if I add a new one, and I'm going to say, oh, this mountain is just going to be very much like that. I'm going to say an 02. Now what we can do is we can go back to our for loop here, and I can just increase this to 2, and now we're going to get a final one here. I'm also going to add a seed. I'm going to add it. And we can see it's changing which ones are being given. So we're getting the round ones, we're getting the slightly bumped ones, then we're getting the very distorted ones here. So it's all working nicely. Finally, we want to get the current frame, which I thought, as you probably would know, it's quite easy to get. We can either add or subtract. I'm just going to add. So I'm going to say plus random of the current point number that we're running over, plus the seed as well. I'll just get driven by that seed. So let me just quickly get rid of this so that I can see what I'm doing. And I'm actually just going to push this all the way up here. So I'm going to say int frame is going to be at frame plus all of that. And it's not going to like it because it's I don't know if actually at frame is a float. I think it shouldn't. I think it is integer. So I'm going to say rint here again, and then I'm going to say int. But yeah, so it must mean that frame is actually a float. So let's say float. I don't need to make this convert this rint to it anymore then. However, what's happening here is because we're reading in. There's a good explanation for why this is happening. So if we go into our geometry spreadsheet here, and we go to our p-scale, we can see that we're getting non-integer value numbers. Now this is good if you have done, say, if you're reading in subframes, but because we're looking at raw input, raw integer ones. So if I go into my global animation settings here, we can see we're looking at integer frame values, and it's step number 1. If we turn it off, we can decrease that step, and you can see now that I can actually go in between these frames. So I'm at 80.72. If I turn that on, you can see it just hit 81. So we want to make sure this is actually an integer. So I'm going to go back and say rint. So, and then I want to fit range this. So fit 1. And then I'm going to say 0, and let's say let's just go min and max. So, and I think I marked that up. I didn't. I'm going to enable them. Go to my edit parameter properties, and I'm just going to increase this range from, let's say, -50 to 0. That's the range, and then 0 to about 50. So now I can really, and you can see like some of them blinked out basically. So what we want to do is we want to clamp this frame range down so that we know that it's always going to be at that, no matter what, it's always going to be at, say, like 0. So the way we can do this is just say clamp this entire value between 0, and we can give it a preposterous value. It doesn't really matter. I'm just going to give it like that much. And I'm also going to make sure this is between 1. So that means that we're always going to get 1. Now you can see that's working. We're all jumping up at different values, different heights. I can change the scale, seed, and so on, and the scatter points. And that's how, if I want to change this seed too, that's how you would do it. One more thing that might be worth noting is I can use a compile block. I hope. I haven't had very good luck with the last time I did compile blocks, but compile blocks basically will take in anything that is non timed. So you can see we've got this little cog down here. If I go into, if I hold my mouse over here and press D to go into the settings, we can see that we've got non-compilable sob badges that's set to normal. I believe by default though they should be hidden. So badges, no needs to cook badge. Let's take a look at that. Nope. HCA locked. Node locked. No. Okay. Normally there would be like a block that can't be compiled. So I think poly extrude might be one. There we go. Yeah. You can see it's got this little cog with like this thing between this stop sign between it basically. This means I can't compile it. And compiling means I'm going to multi-thread it on the CPU. If you don't understand what that means, basically it means I'm just going to, instead of using one thread to copy all this out and such, I'm going to use all the threads. So I'm also going to pack this so that it doesn't, like, yeah, it's going to be packed. So what I'm going to do is I'm going to compile block here. I'm going to plug this in. I'm going to plug this in here. And then inside of here, I'm going to say multi-thread uncompiled. And you can see it's a lot faster to go around now. But what happens if I'm going to say, I'm going to set this to about 20 by 20, so they're a lot bigger. And then I'm going to say 60 by 60. So now that's quite a lot there, but that was relatively fast. It is going to be quite slow to evaluate over time, unfortunately, because it's got to read all these in and load them into the memory, which is why it is probably a better idea, instead of loading them all in like so, what you would normally do. So Francis did this, I think, before. You would use multiple file nodes along here, and then you would use a switch, or you would use a group. I've used groups in the past, so you would do like a file sort of thing. You would say file A, it's going to here. You would get the other one, so I think this one would be 0, 0. So we get basically get 2, and you would either merge them after grouping them. So you would make sure that they have like a group name, so a group, or an ID. So I will group this one. It's probably better to have them give them an ID, honestly, because then you can just change the ID quickly. So I'm going to say ID equals channel ID. So, and you can put it on the points or the basically whatever, and you would just evaluate that. So this is going to be 1. This is going to be 0. And so there's going to be this. So if we go into here, you can see that some of them's got ID 1, ID 0, and you would use a blast with like an expression saying, if, for example, you would use you would use this R value, and you would switch between the R by going 0.0, or -1 because you're going into there, and you're going to say ID 0 again for the point number, then you would say R and then 0 again, like so. And you would evaluate it, and you would say that this is a point group, and you'd say ID equals something like that. You got ID. Let's actually try and do that quickly, because why not? Just copy paste this and get rid of this file node, get rid of this compile block for now. I'm just going to deal with that for now. This blast would be in the inside of our compile block here, and as you can see, nothing is quite. So we've got a lot of points to copy over, honestly. And I'm not even too sure if we're blasting the correct amount of points. So we've got 2,000, 1,000. So yeah, it is actually blasting them all out, which is good to see. It still took a little while to do, as you could tell. But what we would do here as well, so with the frame range, we would do like the frame. So we would do a time shift, and the time shift is also is non-compilable, unfortunately. So what would happen is you would have to have this time shift working as well in a non-compilable block, so you can't compile this. But let's just leave that time shift out of it for now. You can see how slow it's going. It's got to go over every point. I've got to hit escape because I accidentally attached it to that. If I put down a compile block now, compile block, I need to plug one in here. I need to hit stop because it's not actually compiling. Plug one in here. I need to hit stop again. And then you can see it's kind of stretched out over all this. So we need to actually create a meta import node. Hit escape again. I need to keep hitting escape until it actually starts behaving. And I'm going to plug this in here. Hit escape one more time. I'm going to say fetch input. Need to keep hitting escape, unfortunately. And it's still going around here. So then we just need to duplicate this. And what will happen is it'll just shrink instantly. And then if we change, let's change the seed. I didn't see any change whatsoever there. Let's try it again. I saw some change. It wasn't a great deal of change, but there was a change. But you can see it's a little bit faster than waiting for it to compile everything. Unfortunately, you would have to use the time shift node and go for everything like that. I am being kind of ambitious with the fact that I also need to hit escape multiple times because I'm doing 60 times 60, which is basically 60 to the power of 60. Which if we get out our calculator, 60. Where's my I'm in programming mode. My bad. Let's go to scientific. Where's the power? Okay, so 60 squared. 3,600 points that we're copying over here now. So I'm going to say 10 by 10. And you can see it is still moving quite fast. This one's still, I forgot to change that. So I'm just going to quickly go on manual update here, 10, 10, 10, 10 here. You can still see that this is still relatively fast. And it has actually got the frame range working properly as well. So that's the method that we use instead of the CopyStamp. CopyStamp's been deprecated basically, and this is the method that Side Effects recommends. Not this compile block thing. This is what I recommend as well if you want to try and speed it up. But as you saw, we can't speed up some things like this time shift node. We can't speed that up. What I'm also going to do is I'm just going to do one more. Cut that one. Set this to 2. Set this to 2 and 2. I'm going to get rid of this compile block here entirely because I don't really need it. And so you can see that what's happening is it's not quite working. So we've got 2, 1, 0. So it's not deleting the correct ID. So let's take a quick look. So it is kind of deleting it, which is really weird why it's not deleting all of it. So 3,600, yep. Go inside here, it's about 2,000. Oh, right, so we need to delete non-selected, basically. That's my fault there. And then let's put in the time shift part here. And let's get that frame. So I'm going to say, I'm actually going to put F at in frame here, and I'm going to say frame. So I'm not going to use the S input. And inside here, I'm going to say add sphere input. I'm going to say point, -1, 0, because I'm getting the 0th point again. I can't remember what I named the attribute. In frame. So I'm going to say in frame, and then I'm going to say 0 again because it's just a 0 point. And then I need to plug in this read attribute here. So what should happen is some of these points should now stay on the ground. Yes, they are. So these are staying on the ground, basically. And we can see they're now jumping up and down a little bit. But I can't compile this because it's got a non-compilable block inside it. We can try. So if I put down a compile block, duplicate this one, plug this in here, we can see it's crying because no support for compiling this type, and then it just can't compile. So it is actually going to start crying that it can't do it. So that's what we now use. We use the copy the points in a for loop, and that's what we are recommending now. So I'm sorry it took so long to get this video out. More coming soon, maybe. Who knows? I hope so. There was a question in the channel actually. Let's take a look. VEX. Oh, so you so the question was talking about Balthazar. I can't pronounce her name. Balthazar. You were asking about linking material builders with procedural geometry. A volume wrangle is special. It's very special in the sense that you can use, if I lay down a material, I think it's a shop network I need actually. Lay down a shop network, and we go to that CVEX, look at the shader builder here, dive inside, and it's basically going to be a node, or it could be a material network. Let's try, no, let's just use the shop for now. And then you've got like this procedural VEX volume procedural, and what happens here is it needs a shader, so you plug this in here, and you can't exactly dive inside it. But what I'm going to do is I'm going to lay down a VDB quickly, a box, so we can actually start editing it and convert it to a VDB, like so. I'm just going to set this to here. I'm going to make this box slightly bigger, so I've got some room to work with. And then what I'm going to use a volume flop and go inside here. And inside this VEX one here, I'm going to say shop. And I'm just going to put in the shop path, and I actually need to go into the shop network and I need to say this procedural geometry, I believe, or this one. So this one here. Not too sure why this one didn't like it. Inside here, I can do a bind export and a density, and I can do a constant here, and we can see I can actually give it the constant of that. But I can now go ahead and add some noise. So I'm going to bind import the density, bind import the density. So let's say bind then density like so. Plug those two out, and I believe if I delete this, then normally it wouldn't work. It's really weird way it is actually working though. Very weird. Maybe it's changed over the time. I don't know. But we normally used to have 2 of these down. It looks like we don't anymore. But inside here, I'm just going to use the multiply by. I also need to bind in the position. So position is a vector, and I'm just going to create a noise. And now we've got a lovely looking nebulous upper field here. Quick tip for those who don't know. So I'm going to lay down a borrow noise. That's going to look something like this. I'm going to do a subtraction. I'm going to subtract these two from each other and invert it. So we're going to get something similar to this. If I increase the frequency or decrease it, I'm actually going to go up here and I'm going to increase the resolution to 2, so we can really see what we're doing. And you can see how it's very straight lines and so on and such like that. Something you can do to distort that is basically noise up the current incoming position. So I'm going to say a noise, and I'm fine with telling this because this was told by Saber in the now very public creation of rock geometry and stuff. And if I just decrease this down, you can see it is actually distorting this quite a lot. And this is pretty cool in making very, if you keep layering these sorts of stuff on top of each other, you get some very nice effects. I'm going to convert BDB again, and I'm just going to say, hey, convert it to maybe an SDF. See what we get. Get some very weird rock shapes, like floating like asteroids almost. It's quite pleasant to the eye, in my opinion at least. So that's something you can do. I'm not too sure what you mean by trying to link it. If you can give me a bit more context, I'll actually message you and ask for more context what you're trying to do. But that was the video. I hope you enjoyed it. I'm sorry it took so long to get out. I shall see you next time I have to make a video. Also, good work with putting all your questions and such in the channel, because they are quite a delight to see people actually interacting and so on. Okay, see ya.